Okay, so now let's take a look at the values that we just found. We're still looking at the same scenario. We've rolled a 6-sided die 7 times, and we want to know the probability of getting a 1 or a 2 a particular number of times. So we had 7 trials, so n is equal to 7. Probability of success is equal to 1/3, and we're given different values for x from 0 to 7, and we have the probability of those values coming up. So now we want to compute some other probabilities that are called cumulative probabilities. I'm going to move this down to make some more space here. Okay, so first of all, we want to calculate the probability of at most 3 successes. Now there's 2 ways of doing this, and I'll show you the quick way. Well, I don't know which is quicker actually, but I'll show you the first way and then I'll show you a second way. So at most 3 successes, in this case, means we could have 0 successes, or 1, or 2, or 3. So since I have the list of my probabilities here, I could say the probability of anywhere from 0 to 3 successes is going to equal 0.0585 plus 0.2048 plus 0.3073 plus 0.2561. And let's see what that equals. All right, and that comes out to 0.8267. And there's my answer for that. Now that's one way to approach this, but what you'll see later on is that you may have as many as 200 or 500 trials. And in a case like that, it's simply not practical to list all the different probabilities and then add up however many you're talking about. So an approach that would work in general would be to say we're calculating the probability of 0 to 3 successes. So now we can use the binomial CDF function in your calculator. It's right below the PDF function, so again you press second and vars to get there. And we give the number of trials again, probability of success, very much like the first thing. And now we want to give the maximum number of successes. We have to be starting at 0. That's the way the calculator is set up. So as long as we're starting at 0 and it's 0 to a particular number of successes, then we just write down that number of successes, and that turns out to be 0.8267. Okay. So we get the same answer either way, and that's how that works. So now let's take a look at the next problem. It's a little bit different. It's mainly the same, a little bit different. Okay, squeeze that up there. All right, so now we want the probability of, what is it? Less than 5 successes. So if it's less than 5 successes, then it's anywhere from 0 to 4 successes. So again, we could add up those values, and you can do that. But what I can also do is say that this is the probability of 0 to 4 successes. And notice that it has to be a 4 here because it's less than 5, so we can't include the 5. We go right up to just before 5. So think of it this way. Think of a number line, and we have all of the numbers from 0 to 7. These are all the possibilities. And we want less than 5 successes. That means we want anything from 0 to 4. Those are all the ones that are less than 5. So I'll do this the same way I did the last problem. Now, binomial CDF, number of trials is 7, probability of success is 1/3, and now we're going from 0 to 4, so I put a 4 at the end. And this is equal to 0.9547. That's my answer for that one. Okay. Now let's take a look at 2 more problems that are a little bit more complicated. Now I want to calculate the probability of more than 4 successes. Okay. So what I'll do is, first of all, again, I'm going to make that number line. I think it's a nice visual aid. You don't necessarily actually have to do this if you're comfortable, but it kind of helps to figure out what's going on in the problem. So this says more than 4 successes. So more than 4 would be anything from 5 up to 7. So now we're calculating the probability of from 5 to 7 successes. But here's the problem. Remember I said before, because of the way the calculator works, we have to start at 0. So this isn't going to work because we're starting at 5. So we have to be able to adjust this. So what we're going to do is we're going to say, well, we have to start at 0. And what I can do is I can go from 0 up to 4. Now that's the complement of what we want. And we know that we can calculate the probability of the complement by taking 1 minus, or I should say, we can calculate the probability we want by doing 1 minus the probability of the complement. So now we're going to do 1 minus the probability of 0 to 4 successes. And we can type this into the calculator just as we have it here, 1 minus binomial CDF 7 1/3 4. But of course that was the answer that I just got, so this is going to turn out to be 0.0453. And that is my final answer for that. And you can double check this by looking over to the side and, oh, that went off the edge there. Let's see. So this is 1, 2, oops, that's not right. 0, 1, 2, 3, 4, 5, 6, 7, and we wanted 5 to 7, so that would be these 3, and those should add up to 0.0453. So that'll work. All right. And now for the last one, we want the probability of at least 2 successes. So now for this one, we want at least 2, so we're going to include 2 and go all the way up to 7. So again, I could do that by adding, but because that's not always going to be practical, let's talk about how to put it into the calculator. So we're talking about the probability of from 2 to 7 successes, and that's 1 minus the probability of 0 to 1 success. So we're going to type it in as 1 minus binomial CDF 7 1/3, and then the maximum number of successes is 1 because we're going from 0 to 1. So I put a 1 in here. And let's see what that is going to turn out to be. Hold on just. And that turns out to be 0.7366. And that's my final answer there. So that's how you work with binomial probabilities.